Hi, I'm Andy Davidson, founder of the Financial Lifecycle Education Corp, a not-for-profit. We're also known as FiCycle. Our mission is really to connect mathematics to personal finance. And today we're going to be talking about data science and credit scores. This is part one of our series on this subject. So what we'll be examining is the question, am I my credit score from a mathematical perspective? So first, a little background. Financial Lifecycle Education is a not-for-profit that works with educators and organizations to equip all students with the mathematical and financial skills and understandings necessary to navigate their financial life cycle and meet state standards in mathematics. For more information on us, please go to the QR code. But really, our work covers research, standards, courses, modules, and lessons such as this. So first, let's take a few minutes to talk about what is data science and what is credit score and what's the connection between them. So let's take a few minutes to read this. And then credit scores. I want to read that whole definition to you. Credit scores are numerical representations of consumer credit based on mathematical calculations derived from statistical analysis of a broad range of consumers' credit histories applied to the data currently consumers' credit files. That's a lot of words, but I think by the time we're done with this series, you'll understand all of those steps. Then credit scores are designed to enable lenders to evaluate the relative risk of cohorts of consumers based on their probability of making timely payments on financial obligations. And parenthetically, they may not actually reflect the risk associated with any individual consumer. And that's really the question we're trying to get at. Am I my credit score? Now, to see the connection between data science and credit scores, it's highlighted a few words in both of these definitions. So on the data science side, it's statistics, algorithms, and technology. And credit score is definitely statistical analysis. Data science obviously uses data. And the data we're using here is consumer credit histories. And then enhanced decision-making on the data science is the decision we're trying to make is evaluate the relative risk of cohorts of consumers. So if credit scores are certainly a type of data science and a great application and a great way to learn more about data science. So let's delve into it and get started on the mathematics. So we're starting to develop a series of lessons around the mathematics of credit scores, and this video is really just part of that. If you're interested in receiving more information, please go to this QR code and fill out the form. Thank you. So let's get to part one. First of all, let's just talk about odds and probabilities. So what we want to do is sort of just build our general skills in thinking about odds and probability as they're really the fundamental foundation for thinking about credit scores. So first, we have a little box, and in the box are 5 marbles. You can see there's 1 red marble and 4 blue marbles. So given that, what's the probability of picking a red marble? If you said 1 out of 5 or 20%, you are correct, right? So we can either think in terms of decimal or in percentage, but either 1/5 or 20%. Well, if we know the probability of picking a red marble, once again, put the red marble back in, or the marble you took out back in the box. Now, what's the probability of picking a blue marble? That's right, 4 out of 5 or 80%. Now, what about odds? How are odds different than probabilities? Odds are the relationship of one event to the other event. So what's the odds of blue to red? Well, we just count up the blues and count up the reds. And so it's 4 to 1. And what about the odds of red to blue? Well, obviously, we just switched that around, and now it's going to be 1 to 4. Now, this may be simple, but keeping these ideas in mind is going to be very helpful to us as we explore credit scores. Now, before we just sort of show those numbers numerically, but we can also convert those into equations. And how do we relate odds to probability? So an odds is basically the probability that an event happens divided by the probability the event doesn't happen. So the probability of finding something is its probability. Probability of it not happening is 1 minus that probability. So we can see that the odds is the probability divided by 1 minus the probability. And then we can go and see that in an example if we think about the odds of red to blue. So what was the probability of red? Was 20%. What was the probability of blue? 80%. 20% divided by 80% is 0.25 or 1 to 4. Sometimes when we're talking about odds, we're just going to talk about one number. And then if we just talk about a number, let's say n, then the odds are n to 1. So in this case, it would be 0.25 to 1, in which we'd multiply by 4 to get 1 to 4. What about the probability from odds? Well, the odd, that's the event, the probability of something happening is the event happens versus it doesn't happening versus the ratio of all events to the event doesn't happen. So that can be expressed as the odds over 1 plus the odds. And so an example of that, we can say, what's the probability of red? Well, it was the odds of red, 1 in 4, divided by the odds of 1 plus that odds of 1 to 4, or 1/4 over 1/5, or 1 to 5, or 0.2. So here we can see that we have equations that help us convert between odds and probability. Well, we haven't talked about credit scores much, but here, let's now switch and talk a little bit about credit scores. So this chart is based on one of the widely used credit scores called the Vantage credit score. And here we're talking about how well the credit score is related to delinquencies on mortgages. So what's a delinquency? A delinquency is when someone doesn't make their payment on time. And so a 30-day mortgage delinquency means that the person has missed one monthly payment. So what this chart shows, the blue line shows the probability of becoming delinquent. The orange bars show the percent of scores in each of those buckets. And along the x-axis on the bottom are the range of scores that we're looking at. So ranging from a score of about 500 to a score of about 900. And if you look at the shape of the blue line, you see it's not a straight line, so it's some sort of curved line that we can explore later. But let's just look at this a little bit closer and say, like, okay, well, these are measures of delinquency. Well, let's take a pretty, relatively low score. Let's say a 670. So well below the average of the scores that we see, and say, what percentage of those borrowers did not become delinquent? So if we look at this bucket here, we can see that somewhat less than 5%, maybe about 3%, became delinquent. So that means 97% of those borrowers did not become delinquent during this time period. So when we think about credit scores, we have to remember that it's just reflecting a probability, and it's not saying that everyone in a range will miss a payment. Then another question we want to ask is, well, how much of a change in credit score does it take to double the probability of becoming delinquent? So it's pretty hard to say in these numbers. So maybe we'll come back to that question a little bit later when we take a different view. So obviously this model is still pretty good. It's certainly distinguishing between borrowers on this end with a very low probability of becoming delinquent, with borrowers on this end with a very high probability of becoming delinquent. What we're going to explore is how do companies build these models that rank borrowers' risk for delinquency. So in the previous chart, we were talking about probability, but here I just want to switch it around, and now we're going to talk about odds. And instead of talking about odds of probability of becoming delinquent, let's talk about the odds of not missing a payment. And you can see this line looks a little different than the one in the previous slide. It has the opposite slope. So why is this sloping up when the other sloped down? Right, because this is the odds of not missing a payment, or the odds of making all your on-time payments. Now, when we develop credit scores models, we're going to find out that we want to create some sort of linear model. So we'd want the green line to be a straight line. When we look at this shape, how can we make this green line straight? Well, it's where we get to another mathematical tool. Now you see I've turned this curved line into a straight line. Well, how did we do that? Look at the x-axis. On the the y-axis. On the y-axis here, we can see that that's a linear scale going from 0, 50, 100, where each line represents an increase of 50. In the new graph, take a look at the y-axis, and what do you see? Each line actually represents a doubling of the odds. And what do you notice about the shape of the green line now? Oh, you can see it's a relatively straight line. And it's going to be much easier to answer the question I had before about how many points for the odds to double. Doubling of the odds just means we go from, let's say, 32 to 64. So if we go from here, it's 32, roughly in the 670 band. And then we're double that in roughly the 710 band. So it looks like about 40 points, or about 2 boxes for us to double the odds. Much easier than doing that off of the curve chart. So what kind of scale is it that moves things in proportion rather than equal amounts? Yeah, that's a log scale. And so what we can do is we can actually just take the log of the odds, and now we can show the y-axis an equal amount of logs. And then we can show that we can generate a straight line. So instead of using a scale that doubles, we take the log of those, and then we have an equally spaced scale because logs represent numbers that double proportionally. So we can think of credit scores as a transformation of a model of log odds into a familiar range. So we're calculating a log odds, and then we're going to transform that into this range. We'll see more about that as we go through our discussion. So obviously, probability and odds are going to be very important for our discussion. And to understand a little bit more about why we're using odds and log odds, let's delve into that a little bit further. So here I show 2 different columns. The first column is a probability, and the second is odds using that conversion formula we developed earlier. And then here I show the various probabilities, 0.1 up to 0.99 and 0.5 for 50% probability in the middle, with the probability shown in decimal. And then we have the corresponding odds going from 0.01 to 99. So if we extend this down, what's the smallest probability we can have? And what's the smallest possible odds we can have? And what's the highest possible probability we can have? And what's the highest possible odds? That's right. So probability is basically between 0 and 1. Some people will argue in some situations it doesn't include 0, and it doesn't include 1 because 0 is not a probability because it never occurs, and 1 is a certainty. But for our purposes here, let's assume that probabilities range between 0 and 1 inclusive. But what about odds? How small can odds get? Well, the odds can go down to 0. And what's the largest odds can get? Well, if we keep making the probability closer to 1, you can see that the odds will keep going up higher and higher, and we'll basically have no limit. And so they're just less than infinity. Well, what about log odds? Remember, we took the odds, then we took the log of that, and then we then sort of looked at the continuation of that. So what's the range that we can have for log odds? Yep, and once we take the log of something approaching 0, that can approach minus infinity. And once we take the log of something approaching infinity, that's still infinity. And so it's very interesting. Why don't we look at the odds of P and 1 minus P? Let's take a look at a particular example. So for example, let's say we're looking at 0.1 and 0.9. So the odds of a probability of 0.1 is 0.11, and the log of that is minus 2.2. And then if we take 1 minus that, or 0.9, its odds are 9, and its log odds are 2.2. I'm going to let you think about this a little bit further. Like, why does that work out? It seems like a miracle in some ways. But why don't you think about what is the log of 1 minus x? And I've already talked about the range of the log odds, going from minus infinity to plus infinity. So putting this all together, we can see that, well, probabilities range between 0 and 1. Odds range between 0 and infinity. And log odds range between minus infinity and plus infinity. And this becomes very valuable when we try to create linear models later on. Now, maybe you're having a little bit of trouble with the logs. And as a quick little reminder, for those who don't know, PhiCycles actually developed a manipulative to help us understand log rules. And the manipulatives are just plastic pieces that are labeled with a number on each piece, which we'll call a log. So for example, the one in the picture here is a log 2, and this is a log 5 and a log 10. And these manipulatives are designed to demonstrate the rules of logarithms and let students discover those rules on their own. So if you're having trouble with logs, consider using the PhiCycle logs. They're available both as paper manipulatives for free or the plastic manipulatives for a charge. Well, once you've mastered logs, one of the important things we're going to have to do is convert our log odds, that is that straight line that we created on our graph earlier, into probabilities. And so we're going to just go through and just sort of derive that. Once again, I won't spend too much time on that today, but we can see that there's a derivation. We start with the definition of log odds, that is the log of the odds. And remember, we define the odds as the probability is divided by 1 minus the probability. And then we go through a series of steps manipulating the algebra. And eventually we can rearrange the terms and come up with this equation at the bottom, which is that the probability equals 1 divided by 1 plus the log odds, the negative the exponential of the log odds, or 1 plus e to the minus x. So it's 1 over 1 plus e to the minus x is the probability. So if you give me the log odds, I can compute a probability. So let's take a look at that function that we've just created. So if we graph that function, p equals 1 over 1 plus e to the minus x, we put x, or the log odds, on the x-axis, and then we calculate the probability based on that. We can see the equation that's generated. So what's the domain x and the range p of this function, which we'll call the logistic function? Well, we can see x can get very small or very large, ranging from minus infinity to plus infinity. But what about p? Yep, it ranges between 0 and 1. So what this function lets us do, it allows us to create a linear model for log odds, that's sort of the x's, and then convert that output into probabilities, which is what we want when we talk about credit scores. So now let's get a little bit into the data that we use for credit scores. So the credit scores comes from accredited data. We're very lucky in this situation that Experian has provided us with some sample data that we'll get into. And this data comes from something called a credit report. And a credit report is a listing of the data that the credit bureaus are able to produce. And there's various sources for you to look at, either sample credit score reports or even your own credit reports. But what data is in the credit report? So what's usually included is your payment history on lines of credit, that is where you have borrowed some money in the past, the amount of credit currently available, as well as your current and former addresses. What's generally not included is anything about your income, your employment, your savings, your investments, even rent and utility payments, like your phone payments, are not included unless they were sent to a collective agency or self-reported. And Experian has a way for you to do that through something they call Experian Boost. Even the more recent buy now, pay later often is not included in your credit score. Now, you might want different things to be included or not included, but the credit bureaus are subject to a law called the Fair Credit Reporting Act, which limits what data they can collect and what they can report. Now let's take a look at some sample data. So this is a data file that we received from Experian. And this is just looking at one particular borrower. And there's a lot of numbers here, so I'll just give you some quick pointers on this. But this is the kind of data that we can work with in order to develop a credit score. So for example, the column here called account type lists the kind of loans that this person had. And so each type is represented by a code, and then we can go through. For example, the first account type code is 18, and we can look that up and see that that's credit card. We can also see they had an auto loan, which is item 0, sort of code 0. Item 12 is an educational loan. So we can see that this borrower had a variety of loans that they opened at a variety of dates over time. And then we can look at the performance of that loan with additional data. Once again, this may be hard to read. So let me just give you a little bit of a legend for that. And so this takes the payment grid and then says what each of those means. So a C, the string of C's, these are representing different months. And it's saying that the borrower is current on this loan all these different months. B means the history is not applicable. So that means it ended or something else happened. And then let's see if we can find, for example, this one, a 1 and a 2, 1 meant 30 days past due, 2 meant 60 days past due. So we now have the performance of this borrower on all of their loans, either in a payment grid or with these counters that indicate how many times they were either 2 months late or 1 month late, right? So you can see here that this 1 and this 2 correspond to the 30 days and 60 days being late. So with that data, we could start to build a credit model. So for this particular project, we're going to be using Excel. People use many other tools for statistical analysis. The reason we use Excel is because it features many of the tools we need all in one place. And also, as part of PhiCycle in general, we believe that training students on the use of Excel is important because it's the most widely used analytical tool for business and finance applications. So once we have this data, we're going to turn this data into a credit score through sort of typical traditional statistical methodologies. But this is a lot to do all at once, and so we're going to develop this in parts. So this is the end of part 1, but I hope you join us for part 2, where we do a simple analysis where we look at pricing a car using a similar methodology. Well, thank you very much for your time and attention today. And we'll be, as I say, continuing this in parts 2 and parts 3. If you need any more information about PhiCycle, please take a look for it. Please go to the QR code to learn more about us. Thank you very much.